Hello everyone. In this video, we're going to go over three programs that work with strings. First, we're going to be going over a program for copying a string. Then we're going to talk about the program comparing two strings. And then finally, we're going to go through a program about reversing a string. So these three programs use load and store byte quite regularly. So I think it's important to outline these and show how they're useful. So let's get started with our first program here, which is copying a string. Before we get into it, let's look at the data. Our source string in ASCII Z is hello world, as all of them will be, as you will see. Our destination buffer will have enough, well, more than enough space here for the message. And then we have a message for just displaying source and copied. So let's get started with the code. Obviously, we start in main. First, we load our addresses. So for this, we're going to use A1 as our source and our A1 or A0 as our source and our A1 as our destination. And then once those are loaded, we're going to go into actual copying. So this uses the load byte and store byte. So first in line 16, our source is loaded into T0, or that byte is loaded into T0. And then in line 17 here, store byte, we are storing that address or register into the destination. And then after that's done, we branch if we are completed. In other words, if the null terminator is found, we branch to done. As you can see, we use the 0 operator here because we're trying to see if T0 is equal to that. If not, we need to move on. There's still more stuff to do. So we move to the next byte in the source and destination. So in other words, we increment A0 and A1. At that point, we jump back to the copy loop. Once we've gone through every byte, we can now branch off to the done. And this is pretty simple if you've watched my other videos. We printing the source, message, the actual string, copy message, and then the copied string, and we exit the program. So let's take a look. That's assemble, and let's run it. As you can see here, our source is hello world. That checks out. And then the copy message is exactly the same. All right, let's move on to comparing two strings. So we have two strings here. They're both hello world. For this example, we'll do some testing and we'll change these. And then we have three messages depending on the result, right? So if the strings are equal, then our message will be the strings are equal. If first string is greater, that will be the message. And if our first string is less, that would be the message. So to start off here, a similar start to copying a string. We're going to load the addresses of both strings. So string 1 is going to go into A0, and string 2 is going to go into A1. And then we move on to the compare loop. So again, very similar. Very similar. So we're going to load a byte from the first string and the second string into T0 and T1. Notice this one, we're not storing any bytes because we're not writing. This is an explicitly read-only operation. Our next instruction, we have two branches here. So if T0 and T1 are not equal, in other words, if the characters are different, we're going to check to see which is greater. So that's branching off to check order, which we'll get to in a second here. Otherwise, if both are the empty string, then we know, or the empty null set, the strings are equal, so we can branch off to that. Otherwise, if we're not done, we just increment A0 and A1 and jump back. So let's take a look at our check order. If T0, if T0 is less than T1, our string 1 is confirmed to be less. So we're going to jump down to here, display that message, jump to the exit of the program, and exit it. Otherwise, if it's greater, we're going to branch off to the string 1 is greater message. And then print that, and then move on to then program. No jumping needed because this label is right above the exit program. Obviously, we're not going to go, we can't go straight down the string is equal because it's either going to be less or greater when we get to this point. But if both characters are empty set, strings are equal. So we can branch down to here, print that message, jump to exiting the program, and exit it. So let's assemble this and run it 3 times with the three possible scenarios here. So assemble and run. As you can see here, hello world and hello world are both equal. Let's add an exclamation point to string 1. And let's assemble and run it again. Checks out. The first string is greater, as we can see here. But now let's do 2 exclamation points. Assemble and run. Now it says our first string is less, so that checks out. All right, let's move on to our last program here for this video. This is about reversing a string. So this is probably the more complicated one of the 3. As usual, our test string, hello world, is going to be our string in reverse. We have a before message and we have an after message. Probably good practice with this type of situation is we'll just print the original statement first before we change anything. So we're going to print the message, print the reverse string, and now we're going to load the string address. And then we're going to copy the address to find the end of the string. So our first job here is to find the end of the string. So this is pretty simple loop. We load the byte. If it's the null terminator, we branch to found end. Otherwise, we increment and then move on to the loop again. So once we find that, we're going to branch down the found end. And we're going to move back to the last character before the null. And this is an important step because here, back on line 25, we're checking to see if our temporary register is equal to 0. Because 0, that's no character, right? So we need to decrement 1 with sub immediate. You could also do, I've also in the class situation, you might not be allowed to use sub immediate, so you could also do add immediate A1 -1. So that's your alternative method. But regardless, now we can move on to swap loop because remember, we're not branching anywhere, so it just goes down to the next label. So this is a good way to label your parts of the program instead of having one big thing. Anyways, if the start meets the end, immediately we stop. That's what we're going to check every time when we do this. But otherwise, we're going to load the first character and the last character. And we're going to store the last character at the start and the first character at the end. So we're flipping it, right? And then here we move forward from the start and then we move backward from the end. Again, you can, an alternative way to do this that your teacher might want you to do is just add -1, but that's self-explanatory. Since we're not done, it checks at the beginning. It's a for loop. It's not a do while. So we jump back to swap loop and we keep doing that until we're done, right? So if the start meets the end, we're done. So we can branch down the done. We can print our reverse message, print the actual string, and then exit. All right. So that's let us assemble and run. As you can see here, our original message, hello world, is now opposite. So I hope these 3 programs were good examples on manipulating and taking a look at strings using loops, which in turn uses all sorts of stuff like addition, branching, jumping, etc. So if you have any questions, please feel free to comment and I'd be happy to help in the comments, or I can make another video if needed. Otherwise, have a great day and thank you for watching.